Okay, I'd like to introduce case studies in Kyushu University. In Kyushu University, we have 19,000 students and 8,000 faculty members, and all students bring their own devices to the campus. Education big data is collected not only in classroom, but also out classrooms. So we use M2B learning support system, which contains three subcomponents. First one is a Moodle. It can collect the attendance information and report from students. And it also conducts a quiz and provides a link to materials. The second one is the Mahara. It is a kind of e-portfolio system. Students can submit the reflection diary and journals to the system. And the third one is the ebook system, well known as a book roll system, and it can provide a lecture material, and the student can put bookmark, highlight, and text memos on the page of lecture materials. So far, we have tackled mainly in three categories. First category is the analytics issue, so how to analyze educational big data to find out the patterns of learning activities and reading patterns. Second issue is the prediction, so including the change detection or performance prediction for the purpose of discovering at-risk students. And the final one, third topic is the feedback, so how to realize the effective feedback to teachers and students. So today's symposium is closely related to the feedback system because today's symposium focuses on the evidence-based learning. So that's why today I picked up two topics from the feedback system. First one is on-site lecture, on-site education. So what's the difficulty in this kind of large classroom? Perhaps teacher would like to know what students are doing during the lecture. So for example, they are watching the material or following the explanation. The lecture speed is good or bad. So to solve this issue, real-time analytics or real-time feedback is very effective tools. During the lecture, teacher explains the contents of the lecture material, and students are asked to open and browse the same page with the teacher and to put the highlight or memo on the important point. So learning logs are sequentially collected and stored in the database, and real-time analytics is performed sequentially. And finally, visualization is updated minute by minute. So in that case, in the sense, a teacher can browse the real-time activity of the student. So this is a real-time heat map. The horizontal axis is the timeline, and the vertical axis is the page number. So this map is updated minute by minute, and each vertical line represents the distribution of the student. Okay, and the page being explained by the teacher is highlighted by red rectangle. And if the color, bright color, is overlapped on the page being explained by the teacher, so such a case means that most students now browsing the same page, but when the distribution is skewed to the downward, such a case, it means some students still browsing the previous pages. So that's why such a case, teacher should slow down the lecture speed. Here is an experimental result. Teacher adaptively controlled the lecture speed based on the real-time feedback system. Compared with the lecture, normal lecture, without any feedback system, the synchronization between teacher and student was improved. In addition, bookmark and marker are left by the student more than normal cases. And the second topic is related to the lecture material, learning materials. So let's focus on the learning materials that a student is now browsing. So basically, the learning material is provided to the student for the purpose of conducting the lecture. So my question is such a lecture material is proper for preview or review? So here is a very interesting survey. this is a survey of student previewing. The first question is, how long do you usually spend previewing? And almost half of the students spend less than 20 minutes. And the second question is, what kind of material is preferable for preview? And almost 60% of the students require summary, so summarized version of the lecture materials, rather than all contents. So that's why we have developed the automatic summarization technique, which can analyze the original contents, original material, by using the image processing and text processing. And then our technique pick up important pages and make the short summary of the lecture material. And the short summary will be provided to the student for preview or review. This is an example of the summarized material. The original material contains 20 pages. And after the analytics, 4 important pages are picked up, so selected as a short summary of the lecture material. And these pages are given to the student for preview. So here is the quiz score of pretest. So pretest was conducted before the lecture start. And the left 3 results are the score of the students who previewed the short summary or medium length of the summary or long length of the summary. And they all mean the student group who previewed the all contents. And none is the student who did not read any materials. So short summary or summarized materials improved the quiz score compared with the other groups. And the second one is preview achievement. So most of the students who are given summarized material tended to read through all the pages compared with the other group. So even if we gave the students all materials, most of the students gave up to read the lecture material at the middle part of the content. And finally, I'd like to show you the questionnaire. So did you catch essential point from the summarized material? And most of the students could catch an essential point even from the short summary. So that's why they could answer the pretest after the previewing. So today I introduced the 2 case studies. So first one is the on-site lecture support based on the real-time analytics. And the second one is the preview support based on the media analytics. And both of them encourage the student engagement or learning or previewing. So that's all. Thank you very much.